The first one's pretty easy. Probability of a male. Well, look right here. There are 31 people. How many of the 31 are males? Just add those up. Looks like 11, 17. We're done. Unless you can reduce it, which I don't think you can because they're both prime. That is the probability of a male. Now the next one says the probability of a junior given, this means given, it's a female. So first of all, given it's a female, does that mean we just ignore all these? No. Given it's a female means focus only on this row, this column. And next is probability of juniors for this column. So for this column, how many are in this column?
14.
There are 14. And out of those 14, juniors, which is 8. So the probability of a junior, given it's a female, is this. If we reduce that, we get 4/7. This one, probability it's a male, given it's a sophomore. So this time, don't we focus on this row right here, the sophomore row? So we're focusing on sophomore row. And what do we want? The males or the females? We want the males, so it's 5 out of 7. Given, the word given are conditional statements. They really shrink things down. So you got to kind of throw out a whole bunch of stuff and focus, and then take the probability of what's left. The last one, kind of a trick question. Probability of a sophomore, given it's a freshman. So focus on freshmen. All right? Now, how many of these freshmen are sophomores? It is impossible. Okay? This is not possible. It's 0. You cannot get a sophomore who's also a freshman. So we have, given it's a freshman, you cannot find sophomores. The answer is 0. So watch out for those kind of ones. All right. Next one. We're doing a survey. 20% of the people surveyed were left-handed. 30% of the left-handed people are males. 60% of the right-handed people are females in the survey. Now to do this, what's going to happen here? Okay, we're going to make this little tree diagram here. And you'll see in a sec why it makes sense. The tree diagram. The first thing, it's a conditional statement. The first thing is either left or right-handed. So either you're left or you're right-handed. Now, what does it say in the first step? It says 20% of the people are what?
Left-handed.
So wouldn't this be 20%? What would the other side be? If that's 20%, wouldn't this be 80%? So 20% are left, that means 80% are right. Okay, next. 30% of the left-handers are males. So when we get to left hand, do you understand next we're dealing with either they are male or female? So if you're left-handed, 30% of the left-handers, so we're on left hand, we're up top, 30% of the left-handers are male. So right here, left-handed males is 30%. What would be the left-handed females?
7.
Would there be either male or female left-handers? So if we go down here to right-handers, you have male and female as well. So it says 60% of the right-handed people are females. So 60% of the right-handers, so 60% down here for females. And what would they be for males? That's 60, wouldn't this be 40%? Alright, you need to make this table, this chart, kind of a tree diagram to do the problems we're going to get into. It helps a lot. Number 5. Let's think about the chart. The probability of a male given they're right-handed. So which row are we going to focus on? Well, given means we focus in on one of these sides. Leave their left or right-handed. Which one are we focusing on? The right-hander. So aren't we focusing down here? So we focus down here. From there, what's the probability of being male? Focus on right. Male is 40%. We're done. Again, right-handers, male. Given right, male. Now number 6 is a little bit different. The probability of a left-handed female. Left-handed female. Now, that's not a conditional statement. Left-handed female means it's a person who is left-handed and female. Correct? Again, it means it's left-handed and it's female. What does and mean? Multiply. So, what's the probability of left-handed? 20%. And what's the probability of female? Now, the probability of female is 70% because you're going down that side. First, you're probably a male. Second, you're probably a female. So that's 70%. If I multiply those two, won't that give me the probability of it being a left-handed female? Hopefully you can see, you can kind of simplify this down a little bit. Those cancel, leaving you, it looks like 14 out of 100. Which, wouldn't that be 14%? You have a 14% chance of being a left-handed female. How do you find out the probability of being a right-handed male? Don't you go 80% times 40%? Would that give me a right-handed male? Do you understand all these numbers at the end will add up to 100%?